Section 1-2, simplifying expressions. The two objectives for today's lesson are to review methods of simplifying algebraic expressions and to simply evaluate the expressions. First, numerical expression. We need to remember that an expression and an equation are very different. An expression is simply a symbol or group of symbols that are used to represent a number. Okay, that's what an expression is. A value is the number represented by the expression. So if you were to plug in a value for x of 2 and a value of y of 7, and say the expression was xy, it would just be 2 times 7 or 14. So that's the value when you plug in a number. An equation, though, is a sentence that's formed when you put an equal sign between the expressions. So you have two expressions, and when you set them equal to each other with an equal sign, it becomes an equation. An inequality symbol is a symbol that indicates that two expressions are not equal to each other. So either one is greater than or one is less than, but you can obviously have less than or equal to inequalities, which would be exceptions to that. An inequality in general is a sentence formed by placing an inequality symbol between two expressions, such as x is greater than 5. So again, this would be an example like this. That would be an inequality. The actual symbol themselves are the less than or the greater than, or the greater than or equal to, the less than or equal to. Example 1, use one of the symbols to make a true statement. All we have to do here is think about our order of operations. Now we haven't gone over that yet, but you should remember PEMDAS. First, we're going to take a look here. We're going to see division. 27 divided by 3 is 9. So it's 9 plus 4. We do this first for exponent. It's going to be 16 minus 5. So to fill in that blank, we're going to need to figure out the numbers. And 13 is clearly greater than 11, so that's our answer, greater than. So just to review the basic operations in some terms, sum is when we're adding two things together. Product is when we're multiplying two things together. Difference is when we're subtracting two terms, and quotient is when we're dividing two terms. Next, three definitions: power, base, and exponent, that are all related to each other. Power is the product as a result of equal factors. For example, 3 times 3 times 3 times 3. Okay, when we multiply the factors by each other. Well, the base in this case would be 3, and the exponent in this case would actually be 4, because this is really just 3 to the 4th. Okay, so again, the base is the bottom part, and the exponent indicates how many times it's repeated. This is assuming the exponent is greater than 0 for repetition purposes in the numerator. Substitution principle tells us that an expression can be replaced by another expression that has the same value. So, for example, something simple as 14 minus 3, well, that's 11, so you can replace it with 11. But you might say, why do I care? This is just subtraction. It's not really substitution in a sense. The way to think about substitution is to think about variables. So imagine you had a situation where you had a design of some sort of an engine, and you had everything in terms of the radius. So you wrote your whole program in terms of a radius, but there's no value of the radius. Everything's in terms of r. Well, if I write 1/2 d, that's the same thing. The radius is simply half of the diameter. So if I wanted to use substitution principle, I could go into my program, and wherever I have a variable r, I can replace it with 1/2 d, assuming that the diameter is the value that we know. Order of operations, remember PEMDAS. First do parentheses, next do exponents. Now here, we have to think about left to right. And what I mean is this: if you had a setup like the following, you have to go left to right. 24 divided by 6 is 4. Leaves 4 times 3, so we do this first, which is 12. Had you had done this differently, you would have ended up with 24 divided by, and if you multiplied this first, this is 18. 24 divided by 18 is not the same thing as 12. So clearly we have to go left to right, or we're going to get different answers. And the same applies to addition and subtraction. So in that area, you also go left to right. But remember to do this first, and then move on to addition and subtraction. Let's look at an example of that now. So example 2 says to simplify the following. So we'll start with parentheses because of PEMDAS. So we reduce whatever this is, which gives us 3. Then we go to exponents next. 3 to the third is 27. After that, what we have to think about is going multiplication and division from left to right. So divide the 27 divided by 9 to give you a 3 here. After this, we have to carry down our minus sign here. We have to remember that 3 times 6 comes next, because we have to do the division factors and the multiplication parts first. 3 times 6 is 18, and then we carry down the plus 12. At this point, left to right again. 3 minus 18 is negative 15. Negative 15 plus 12, giving us an answer of negative 3. A variable is defined as a symbol, usually a letter, that is used to represent any member of a given set. And usually we call this set the domain of the variable. Inside of the set, the domain. So all of the possible values that it can take on. Now let's take a look at an example that involves variables and evaluating an expression that has a variable in it. So example 3 tells us that if x is 7 and y is 6 and z is 3, evaluate the expression below. And we start by simply plugging in here. So let's plug in 7 plus 3 over 6 plus 7 plus 6 over 3. This is going to give us 10 over 6 plus 13 over 3. At this point, use a common denominator. It's not worth it to make it into mixed fractions and try and add. Keep them improper, but find the common denominator. Clearly, I can multiply this by 2 over 2, and that'll give me the same denominator here. Okay, again, this becomes 26, this becomes 6. 10 plus 26 is 36 over 6. Okay, and then 36 over 6 is just 6. So a problem like this, we have a few steps to go through, but again, make it easier on yourself. Find the common denominator instead of using mixed fractions. Let's take a look at this last example. Use 5 2's to write an expression whose value is 7. So some of them might jump out right away, and there's many answers. I'll go through a few of them. But if you try and think about 2 plus 2 plus 2 plus 2 over 2, this gives you just 7. If you try 2 times 2 plus 2 over 2, this also gives you 7. And you can try 2 to the second plus 2 over 2 again, and still you get 7. So there's many ways to write the number 7 using 5 different 2's. Again, 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you can do this many different ways. So you can try on your own to come up with other ways to get the value of 7 using 5 different 2's and some of our operations. Your homework for this section is to take a look at section 1, 2, 9 through 51, multiples of 3. So again, 9, 12, 15, 18, etc., multiples of 3. And then on page 5, which will be a review for you, you'll do some review problems from section 1, 1. It's the mixed review section, 1 through 11 odd.